Okay. A translation is a slide, which you call an elementary, but you do need to know the actual name. It's a translation. So remember, it doesn't change orientation, it just moves. It looks exactly the same, just a different position. Now, there's two ways to write translations. Coordinate notation is the long way. So here's an example of a coordinate notation. So, all this means is you take each point on the graph and slide the x's right 3 and the y's down 2. So this just means right 3 down 2, all of this stuff. The short way to write it is as a vector. A vector is just directions how to get from one point to another. Airplanes flying vectors. So on a graph, we'll just say you start there and you end up here. The vector would be drawn like this with an arrow at the end. And the way you get there, now this is the same concept as slope, it's just it's not rise over run. Like I said, slope, Donnie.
Oh, there's nothing funny.
No, then take them out. Slope is rise over run, but it's the only thing in math that goes up first. Everything else is run over rise. So when you explain a vector, you go over 1, 2, 3, 4. So you'd say right 4 and up 1. That's using words. If you wrote it as a coordinate notation, you'd be like this. X plus 4, y plus 1. Now the easy way to write translations is in component form. And I showed you this before. That's with these brackets. This one would be over 4, up 1. So you put these brackets to show this is a direction, it's not a coordinate. So don't get these confused with a location. So if I wanted to rewrite this translation in coordinate form, I'd put what and what in there? 3 and -2. These two mean the same exact thing. It's just two different ways to write them. In a vector, you have an initial point and a terminal point. And hopefully everyone here would be able to figure out what those two mean. Yep, starting point. Terminal point is where you end. You know, they call the airports, what? Terminals. So, just like all the other things, a translation is an isometry, which means it will not change size or shape when you slide it. So here they got an example. They took this segment and they reflected it to there. You can see the prime marks. And then they got another line, they reflected it over that. So this theorem says if you reflect something over two parallel lines, it's the same exact thing as, just imagine this wasn't there. From here to here is just a what? Slide. Translation. So, like on those rotations, remember if you reflected something over two lines, it's the same thing as a rotation, and you just double the angle. If that's 70, it'd be a 140-degree rotation. Remember the last assignment? Yeah. So if you reflect something over two parallel lines, here they crisscross, they intersect, but if they're parallel, it's the same thing as a translation. So, like I said, these are the easiest ones to do. The rotations are the most confusing. Here's the original. We want to sketch the image after this translation. So all this means is x is plus 4, that means right 4. Y is minus 5, so that means down 5. Remember, negatives are left and down, positives are right and up. So you just take each point and do that. Right 4, 1, 2, 3, 4, down 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. So there is the new triangle. So when you do these are a lot easier to find the new coordinates than the rotations without graphing them. On the rotations, it's kind of hard to remember those rules, so you're easier off just sketching it to find them. Here, all you got to do is look at this. Here's the original coordinates. So the new coordinate A would take the x and add 4 to it. Take the y and subtract 5. 7, negative 2. Take the x and add 4. Take the y and subtract 5. 2 over 3 down. Take the x and add 4. And take the y and subtract 5. 5, 0. So that's why these are a lot easier. You can just use this to find the new points.
So these we don't need an assignment, right?
That's not right.
So it's, you just use whatever formula I gave you? For
Yep. So in this picture, A is left 3, down 1. Negative 3, negative 1.
Okay.
B is over 3 and up 4. C is over 4 and down 2. So instead of drawing it, you can just use the rule to find the new points. A prime is x minus 6, would be negative 9, and y plus 3 would be 2. X minus 6, 3 minus 6 is negative 3, 4 plus 3 is 7. 4 minus 6 is negative 2, and negative 2 plus 3 is 1, without having to graph it. Now, the vectors. Here, C is the initial point because D has the arrow on it. Can everyone see the arrow at the end of that?
Yeah.
Okay. So that means it's going from C to D. And again, I just got to keep saying it over and over. It's not slope. You got to go side to side first. So the way you label this is whatever the starting point is, you put first, and then you put the terminal second, and then the label for a vector is just like that. It's like array, except it's just got one barb like that. So this is vector CD. This one starts at P and goes to Q, so you would name it as PQ, like that. So when it says name the vector, that's all you got to do. And then when you write the component form, that's the directions, how you get from C to D. So to get from C to D, I got to go over 1, 2, 3, 4, and go up 3. So forget about slope. Here from P to Q, I got to go left 1, 2, 3, so it'd be negative 3, and down 1, 2, 3, 4. So the vectors are real easy, you just got to remember go side to side, then up and down. So component form of vector JK is 3, 6. We're going to use JK to translate triangle DEF. So again, it's exactly the same type of problem, they just worded it different. Since this is a positive 3, that means you go right 3. And since that's a positive 6, you go up 6. So each point goes right 3. 1, 2, 3, and up 6. So there's D prime. 1, 2, 3, 1, 2, 3. There's E prime. And F prime. So this is just another way to write it. Everyone see that they're the same?
Yep.
Okay. So again, you don't need to draw these. Since A is left 2 and up 5, I could find a prime by doing this vector, by taking the x and subtracting 4. Negative 2 minus 4 is negative 6. 5 plus 8 is 13. B prime, B is over 3 up 0. So take the x, subtract 4, negative 1. Take the y, add 8. And then C prime, C is over 1 down 3. Take the x and subtract 4, negative 3. Take the y and add 8, 5. Same exact problems as we did on the top one, except they didn't write it the same way. So here you just have to add 0 to the x. So A prime would be negative 2, and subtract 6 from the y. Okay? So make sure when you're drawing a coordinate or writing a coordinate, it's the rounded ones. When you're doing directions, you gotta put the like less than and greater than signs. That's it.
Yeah.
Yeah.